Hi, we're Duped, an ingredient-level intelligence engine that helps shoppers find skincare products that actually match what they need without overpaying. Skincare today is really messy. There are tons of products, most of which are repacked versions of the same ingredient list. Prices range from $10 to $300 for formulas that are nearly identical. Consumers don't know what matches their skin or what they're actually paying for. Consumers want simplicity, transparency, and affordability, but the entire process is manual. No one can part 30 ingredient list and compare 5 serums in their hat. They just give up or overspend. That's why we're building Duped, an AI-powered dupe finder that helps you find products with the same functionality at a cheaper price. Dupe is your ingredient analyst. You can just snap a picture, search on the go, and it will find functional dupes with the cheaper prices and also flag high-risk ingredients. We will walk through how we handle data, embeddings, retrieval, microservices, and also deployment using modern MLOps practices.
First, ingredients. We tried the largest Kaggle ingredient dataset, which had about 2,000 entries, but we found through EDA that only around 300 of those ingredients were in our products. To solve this, we built a custom scraper that collected over 26,000 cosmetic ingredients and their descriptions from scientific literature, making it larger than any other public dataset we found. For the products dataset, we used a Kaggle collection of 19,000 skincare, makeup, and fragrance products. This includes full ingredient lists and labeled skin concerns. We tried several embedding strategies. Simple ingredient overlap is interpretable, but it didn't account for different ingredients having similar function. TF-IDF highlighted specific functional ingredients better, but it didn't generalize well to all categories. We found that using a functional cosine similarity method was the most balanced. For this method, we designed a two-stage embedding workflow. First, we embed each ingredient using a sentence transformer based on its scientific description. When we show these embeddings using UMAP, we see that groups with similar functions, such as acne treatment, are clustered together. Then a product embedding is computed using the embeddings of the ingredients it contains. We use a recommender agent to do the following. First, we retrieve the dupes using Qdrant. Then we fetch the images, URL, and prices using SERP API. Additionally, if that product isn't found in our database, the agent creates a more specific search query based on the product input and uses SERP API to find that product. While some of the parts could have been done without an agent, having an agent allows us to account for user errors such as typos and makes it more robust for future expansion.
We added an interaction safety layer with color-coded hazard levels so users don't unsuspectingly combine risky ingredients. It runs as its own microservice to keep our concerns separated and integrates into the main recommender flow via a simple API call. Our system follows a modular microservice architecture. Each major function, embedding, recommendation, interaction checking, data ingestion, UI, etc., is isolated into its own container. This allows independent scaling, independent upgrades, and clean debugging.
The end-to-end pipeline is fully containerized and deployed using GCP Vertex AI in Google Cloud. We use Kubernetes to scale the cluster and all the containers using a horizontal pod allocation and load balancing features. Quadrant database was used for embedding storage and query retrieval with orchestrated actions via GitHub for full lifecycle. GCS was also used for data storage and data versioning. This ensures our system remains fully manageable, scalable, and production ready. When it comes to the challenges, we identify a few challenges: ingredient parsing inconsistency on the structured text when searching queries, cost trade-offs with the using LLMs or API versus free options and alternatives we could use. Some of the limitations we could not deliver on time is formulation-specific data. Despite having ingredient list, there is a desire to know the ratios of the ingredients and the ingredient search capability, which will enhance the experience to the user.
And now it's time for a demo to make sure you get the typing exactly right and find what you want. And then you hit Discover Dupes, and it loads. All right. And here you can see 5 dupes. These are not the same product. They just have the same image. You've got high matches with reasonable prices and product links that do work. And we can also search by photo And here you can see our fallback option in play. These are 5 more dupes with good prices and roughly the same functionality.